Hello students, yeah, welcome to Math Hub. So in this video we'll be taking stoichiometry calculation. So I'm going to teach you a very important system or tactic that will help you to get most of the questions under stoichiometry or calculation in chemistry. So let's jump into the video real quick. So this formula here is a very important formula that will help us in most of our calculations. So we have mole is equals to mass divided by the molar mass. Okay, the unit of mass is in grams. Okay, this is in grams. Okay, this is in gram per mole. Then the unit of mole is normal mole, MOL. So once you know this formula, mole is equals to mass over molar mass. Trust me, your problem is half solved. Okay, now let's take some questions. Okay, let's take some questions. I'm teaching the ratio method, the ratio trick that will help you to get most of the questions in stoichiometry. This is the first question here. So we have to use this equation for this question. When 2 mole of N2 is nitrogen gas, reacts with sufficient H2, how many moles of NH3 will be produced? So NH3 is ammonia. This is hydrogen, nitrogen, and ammonia. So we have to use this equation to know how many moles of NH3 will be produced when 2 moles of N2 react with sufficient H2. So in this problem, the amount of H2 is in excess. Okay, while N2 is limited. So nothing concerns you with the H2 for now. Okay, because we're told that it is sufficient. So our focus will be on N2 and what we want to find, which is NH3. So this is a ratio trick. Very, very simple. So this is how to use the ratio trick or method. First of all, get the molar ratio from the equation. So my focus is on N2 and NH3. So I'm going to write, look at the question, how many moles of NH3 will be produced? So I need NH3. So let me just put it at the top. My ratio should be NH3, because this is what I'm looking for, divided by N2. So this is the ratio I'm going to form. So let me form that ratio from this equation. Use the moles. There is 2 in front of the NH3. So you write 2 here over. Imaginary 1 is here. So you write 1 here. So the ratio of NH3 to N2 is 2 over 1. That's for the molar ratio from the equation. Then get the molar ratio from the question. Okay, I'm still using NH3 over N2. So if I do another molar ratio, but this one will be from the question now. Okay, so I will do NH3 over N2. Now NH3 is not known. I'm looking for it. So I'll write X divided by, check the question, you see the moles of N2. That is 2. So I'm going to put 2 here. Okay, so these two answers now, these two guys, you now equate them together. You equate them. So you just do 2 over 1 equals to X over 2. When you cross multiply, you get to X. So X will just be 2 times 2, which is X is equals to 4. So X will be 4 moles of NH3. That's what will be produced. Okay, so the answer is 4. So that means 2 moles of N2 will produce 4 moles of NH3. Okay, so then take another question to solidify the knowledge. Okay, let's try on that one. Here's another question. If 3 moles of H2O are produced, how many moles of oxygen will be consumed? So this is a reaction between hydrogen, H2 plus O2. So we don't write hydrogen as H, you miss the answer. It's always H2 because it's diatomic. So when hydrogen and oxygen react, you're going to get H2O as a product. But you need to balance this equation. So to balance it, just put 2 here. Then you put another 2 here. So hydrogen will be 4, oxygen will be 2. So it's not balanced like this. So let's look at what we're looking for. How many moles of oxygen must be consumed? Our focus is on oxygen. Okay, now let's look at what we are given. We are given H2O. So let's form the relationship between O2 and H2O. Okay, so my ratio will be like this. Since I'm looking for oxygen, I'm going to put it at the top. So I'm going to write O2 over H2O. This is the ratio I'm using. So first of all, get the ratio from their equation. Check this equation and get the ratio. Oxygen has 1 here, imaginary 1. So write 1 here, divided by H2O has 2 in front of it. Write 2 here. So this is the molar ratio from the equation. The next one is to form the molar ratio from the question. So I'll do another O2 over H2O. So it's on the question now, from the question. So I'll check the question now. 3 moles of H2O are given. I'm looking for oxygen. So oxygen will be X. So this one is not known. This one is known. It is 3 in the question. So this is molar ratio from the question, molar ratio from the equation. So equate the two of them. So you have X over 3 is equals to 1 over 2. So it's X you are looking for. Cross multiply. 2X. Cross multiply, you have 2X is equals to 3. X will be 3 over 2, which is 1.5 moles of O2, of oxygen. So the answer is 1.5 moles of oxygen. So it's very, very simple. That's how to use the ratio method. So this technique also works whether you have grams in the question or mole or whatever you have, it will still work. Okay, let's try this question and let's see what we're going to get. So use the following equation. This is the equation that you are given. So they are told that how many moles of O2 are required to combust 1.5 moles of C3H8. C3H8 is propane. So you're telling us how many moles of this is required. So what we are looking for, if you see the question, how many moles, we are looking for O2. So O2s are unknown. Okay, so let's form the molar ratio from the equation first. So molar ratio from the equation, you're going to get, I'm doing O2, that's what I'm looking for, over C3H8. So let me get that molar ratio now. Oxygen, there is 3 in front of it, so around 3 here. C3H8, imaginary 1 is here. So just put 1 here. So this is molar ratio from the equation. Now let's do the molar ratio from the question. So I also need O2 divided by C3H8. So from the question, I'm looking for O2, that will be Y divided by, then C3H8 is 1.5 in the question, that's 1.5. So all I have to do is just equate these two guys, equate the two of them. We get 3 over 1 is equals to Y over 1.5. Cross multiply, so Y will be 3 times 1.5. Y will be 4.5 moles of O2. So 4.5 moles of O2 will be used up or consumed during that reaction. So that's the answer to the first one. So in this next one, we are told that how many moles of CO2 are produced? How many moles of CO2 are produced? The same way, just relate it to the ratio. So now I'm looking for CO2 now. Let me just form a relationship between CO2 and C3H8. Okay, CO2 and C3H8. So I need CO2 divided by C3H8. So go to for the molar ratio from the equation. Check what is in front of CO2. CO2 is, there is 3 here. Then there is 1 in this one. So the answer will be 3 over 1. Okay, now molar ratio from the question now. CO2 over C3H8. CO2 is what I'm looking for. So let me call it X. The molar ratio from the question, that's C3H8. You can see that it is 1.5. Okay, so that's why it's 1.5 here. So equate the two of them, equate these two. Get 3 over 1 is equals to X over 1.5. X equals to 3 times 1.5. Then X is equals to 4.5. That's the answer, 4.5 moles. Okay, 4.5 moles. So this one here, 4.5 moles of CO2 are produced. So the two of them are the same answer. And you can also use a faster method to know. You can see the relationship between C3H8 and oxygen is 1 to 3. That's the ratio, 1 to 3. Okay, C3H8 and CO2 is also 1 to 3. 1 to 3. So you can see the 3 that is here. So that means the answer of this oxygen will be the same answer for this one too. So and the former answer for oxygen we got 4.5. So that means this one too will be 4.5. Okay, so it's the same idea. Then the next one, so how many moles of H2 are produced? How many moles of H2 are produced? So let's do it like this. So I'm looking for H2 over C3H8. That's my ratio. That's what I need to form. Okay, so if you form that ratio, check the question for the molar ratio from the equation first. So check it here, you see it. Hydrogen has 4, C3H8 has 1. Okay, so just put it there. Hydrogen is 4, C3H8 is 1. So it's 4 over 1. The molar ratio from the question is H2 over C3H8. This one will give you X over 1.5 is the ratio from the question, 1.5 mole, that's for C3H8. Then just equate these two guys. You have 4 over 1, X over 1.5, cross multiply, X will be 4 times 1.5, X will be 6 moles of H2. Okay, so that's how to use the ratio trick for any stoichiometry question. Okay, even if it's grams or moles, it applies. You can also apply it. So go ahead and try this question on your screen and post your answer in the comment section. Okay, I thank you for watching this video. I hope you have gained one or two things. Okay, make sure you subscribe to this channel. I'll see you guys in the next one. Take care of yourself. I love you guys. Peace.